All right, so nobody really uses the byte or the short primitive type anymore because memory is not at a premium like it used to be. But bytes are still useful. What's the range of value that we can store inside of a Java byte primitive? Positive 128. All right, so the byte primitive can hold unsigned or can hold signed integers between negative 127 to positive 128. When we just think about that in terms of numbers, that doesn't mean a whole lot to us, right? But I did mention back then when I first introduced those primitive types to you that sometimes you will see bytes still being used in the event that we're streaming video or something like that, where things are arriving 1 byte at a time or arriving in chunks of bytes. So we're going to have to work with bytes in here as we read our file. So we're going to start with something small. And let's see. So let's get ourselves a binary file. So we're going to do rickrolled. We'll start with an image. You've been rickrolled. Perfect. So we'll save image as. Actually, I'm not sure what the format of this is. We'll just do view image.
JPEG.
Is it a JPEG?
The name of it, right?
Well, right, but I'm not sure if it's downloading as a JPEG. Doesn't matter. I'll have it in a second. Yep, JPEG, fine. Good. All right, so now we need to put this into our directory that we created last time for sharing files, right? If I remember correctly, we have, let me open up Eclipse here. And we're going to start off by just reading this in and spitting out the result. All right, so this is the client, correct? You're doing all that inside the client? Okay, and I'll go ahead and open this up in System Explorer. And here's our folder called My Files, and I'll go ahead and drag our, oh, not that guy. Drag our rickrolled picture in there. And then we're going to need our terminal. Hello. Oh. I'm getting rickrolled all over the place. Freezing. All right. Oh, that's that one. Okay, so here is my client application, although we probably, well, this is fine. We can run the client from out here. So we'll go back in. I'm going to go ahead and start up the server. All right, so our server's running, then I'll launch the client, and we should see that this additional drawback driver.java, that we now have the additional we're going to share. And here are our files in the folder, and we notice that number 3 is rickrolled links header.jpg. So the idea is we want to be able to read that file in. Okay, and I'll choose 3 there. Okay, so notice we're trying to read this in as a text file, and this becomes a problem. All right, so notice all the little question marks there? That's it reading in bytes and not knowing how to interpret them. All right, so I just read in that file. Last time we had it reading in text. All right, so there's rickroll as text. Don't want that. All right, so we're going to go back in. Go ahead and kill our server here. We'll go over to our client where we just have this monolithic main, and we'll keep it this way for right now. So right now we are opening up a socket connection to our local host. Still going to do that. We need to have the ability to read something in from there. Still going to do that. We need to have the ability to write something out to our, or to read something in from our terminals. This is read in from the server. This is read in from the terminal. Then we have our ability to write to the server. Now this is going to be a little bit different. Right now we're writing out with a print writer. This is for text. Ultimately, I'm going to have to be writing out with binary data. Okay, so I'm going to have to be using some sort of stream to write stuff out. All right, so we'll come back to that. We're going to read it in locally first. Then we'll go ahead and we'll print out the back and forth we have. If the answer is shared, then we'll show them our directory, blah, blah, blah. Which file would you like to share? We'll read that in. We chose which file to share right here, and this is where we actually read that file in. Okay, so we used our scanner to read from that file. Now what we want to do is we want to replace this. We're just going to assume all our files are binary files now. Okay, so we're going to replace us reading that file in with our scanner with doing it with a file input stream. Let's open up the documentation. I'll click on file reader for a second here. Okay, so file reader is an input stream. Notice this guy is for reading in character files. If I go to a file input stream, this receives bytes from a file. Okay, so a file reader is a way of reading in things from a textual file. We need to read in bytes from this guy. How do we create a file input stream? Well, one of the ways we can create it is with a file object. Good enough. So we're going to go ahead and use that constructor here first. We already have our file object called the file. I'm going to create a file input stream. Fizz is equal to a new file input stream, the file. I'm going to go ahead and kill that extra loop we had there. So we're going to be rewriting it. And I need to import java.io file input stream. So now I have access to it. Okay, now once we have our file input stream, a couple different ways we can construct it. We did it with the file. We have a bunch of stuff available to us. One of them is returns an estimate of the number of remaining bytes that can be read or skipped over from the input stream without blocking by the next invocation of the method from this input stream. This comes down to thread safe type stuff, whether or not if you have more than one thing reading from the same file. So let's go ahead and call that available method and just print the answer out. So we're going to say system.out.println num bytes is equal to phys dot available. All right, so we'll write that out. Now, before we go any farther, let's go and look at that file and see how many bytes we expect it to have. Let's go back to our Finder. We'll go into our My Files directory. Here's Rickroll. This guy is 46 kilobytes. Now, that's probably a rounded number. All right, you typically don't see something like 46.128 kilobytes or something. So 46 kilobytes is roughly how many bytes? 47,104 bytes ish. Okay, so let's see what available gives us. We print out the number of, we haven't read anything from it yet, so available just gives us the number of bytes that are remaining on this stream. And since we haven't read anything yet, all of them should still be available. Okay, and let's see what we get. So I'll go ahead and I'm going to run our server in Eclipse. And then I'll go out to the terminal. Need to compile again. Run. We're going to share. Number 3, 45,626 bytes. Right ballpark? E. All right, fair enough. All right, so now we need to read in bytes. Now a byte is just a number, correct? Okay. When we display a byte to the screen, what does it look like? Does it look like a binary number? Does it look like a decimal number? Bytes can hold what range of values? Negative 127 to positive 128? Those binary or decimal numbers? Decimal. So the system.out.println statement, that guy knows how to display bytes, but when it displays bytes, it displays them in decimal, base 10 format. Okay, so if we're going to write out all the bytes, we're going to get a whole bunch of base 10 numbers. So let's look at that. Go back to the documentation here. We can read a byte of data. Okay, well, why don't we do that? We can also read, we're going to be looking at buffered reader stuff, but for right now, let's just work with 1 byte at a time. We can also send in a byte array and it'll read in that many bytes at a time. So I'm going to actually take you through kind of the evolution of this a little bit for network programming. Initially, we're going to read a single byte. Keep it simple. All right, so I'll go ahead and stop this for right now. Even though I guess I didn't have to stop it, but whatever. All right, so right here we want to read in all of the bytes and display them to the screen. All right, that's what we want to accomplish here. I'll elevate this so you can see it a little bit better on the screen. Okay. How many bytes am I reading in?
1.
Well, I'm going to read in 1. How many bytes am I going to read in total? Phys.available, number of bytes. Every single time I read in a byte, let's just go and do something here real quick. I'm going to say, we print it out phys.available. Then I'm going to say phys.read.
Could you do the files blank?
You could. Hold that thought for a second. I want you to see what happens to phys.available after we read in 1 byte. All right. So right now I'm printing out phys.available. Then I read in 1 byte and do nothing with it. And then I print out phys.available again. Okay. We should see this go down by 1. Now, one thing for us to be careful about is when we look at the documentation here, notice that available returns an estimate of the number of remaining bytes that can be read or skipped over from this input stream without blocking by the next invocation, blah, blah, blah. Okay, so this guy is an estimate. Returns 0 when the file position is done, or beyond the end of file. EOF is end of file. So we can keep reading bytes from this stream as long as available is greater than 0. Correct? Well, let's see it count down once. Go ahead and run our server. Go over to the client, compile it again, run it. We're going to share number 3. There's our number of bytes to begin with, and we read 1 in, and we saw it count down by 1.
What's your IP? What's your IP today? Just out of curiosity.
All right. So I'm doing everything locally anyways right now. All right. So in any case, I need to write the code that will read in a bunch of bytes. So I'm going to say while phys.available is greater than 0. So as long as there's still bytes to read, what am I going to do with it? I'm going to say system.out.println phys.read. Reading in 1 byte at a time. So this should display 45,000 and some change bytes to the screen. Make sense? So this is going to run 45,000 times. But it should eventually finish. All right, so we'll go ahead and run the server again. Yeah, my IP?
Yes.
Oh, I don't have it. I didn't write it down.
Oh, here, I'll show it to you. I'll leave the server running since we're not changing anything on the server. If you just want to test your local 172, 31, 228, 162. Right now, the only role the server is even playing is just this little back and forth thing where we type in share and that kind of stuff. We're not actually sending anything over the server. I'll leave it running, so for those of you who have broken servers, if you want to test your client. You have a broken server, right?
I have a broken server.
I'll remind me at the end of class. I'll put it up on GitHub.
Huh?
Start your thread.
Yes.
Okay, so what was I doing here? I started the server, didn't I? Started the server. Now we're going to go back here. We're going to recompile. Then we're going to run. We're going to share. And now we should see a whole bunch of bytes. So there's my 45,000 some odd bytes. Okay? Now that doesn't look very geeky because it's not in binary. So we probably want to put that in binary so it looks all geeky. Okay? Bytes mean nothing to us from a digital perspective. We look at this and 204, underneath the hood, that's going to be an actual binary number. It's the zeros and ones that are going to be sent over the internet. That makes sense? Now, a couple of interesting things we can do. If you wanted to kind of hack at this, for instance, how do I create a, let's say you couldn't figure out how to write a binary file over a socket. Could you create... Could I send, for instance, 204 as a string, then 67 as a string, then 234 as a string, convert them to bytes on the other end, and write them back out to a file? Fill up a file with those bytes? I could. Okay, if you understand how bytes work, how I'm transmitting these over the internet isn't really important. It's reading them initially, collecting the data, and then filling a file back up with the data on the other end. Creating a brand new file and then filling it up with those bytes. But you need to make sure you're putting bytes in there that is bytes of data as opposed to bytes that are characters that you're writing to it as text, which we saw a few minutes ago with all those question marks and crap like that. Okay, but let's make this matrixy and we'll get our zeros and ones. So if I have a binary, if I have a byte value, like I have right here, phys.read. How do I make that a binary number? I should have probably, can I minimize my console? Is that this guy? Okay. So here I'll just say byte b is equal to phys.read. How do I get the binary equivalent of B? Well, how do I convert the number 224 to binary? Should be something we should be asking ourselves right now that I highlighted the number 224. What values can bytes hold?
Bytes.
Yeah, a byte.
Negative.
Negative 127 to positive 128. Okay. Unsigned byte. So you're coming back as unsigned byte. So 224 is legal. 0 to 255 is the size of our bytes that are coming back. Make sense? 0 to 255. How do I, so here's a 255 right there. You shouldn't have anything bigger than that, otherwise we'll have problems. So how do I convert 140 from decimal to binary? Just a normal math problem that we've dealt with a bunch of times. So I have the number 140. Decimal to binary. Keep dividing it by 2 and recording the remainder. Okay. So let's write a little function to automate that. Let me take these spaces out now. Just so we can appreciate the binary. This isn't going to do us that much good long term, but it'll only take a second. So static string byte to byte to binary. This guy will take in a byte B as a parameter. Aye. All right, we're killing it. Server's dead. I'll start it back up momentarily. So byte to binary, what this guy is going to do, he's going to continue as long as B is greater than 0. I'm going to build a string. String S is equal to the empty string. I'm going to say S is equal to B mod 2 concatenated with S, and then B is equal to B divided by 2. Oh, it wants me to cast this to a byte because that's going to be integer division. Which should work. Parentheses around these. All right, and then ultimately I'll return S, which should be my string. All right, so now instead of fizz read here, I want to say driver dot byte to binary fizz dot read. Okay, and notice this guy takes in, I've written it to take in a byte, but notice it thinks that that guy's returning an int. So it thinks fizz.read returns an int. If I type in fizz. Actually, let's just look at the documentation real quick. It'll show you the same thing. If I go to the documentation, and we go to the read method here, it says it reads a byte of data, but what's it actually reading in? An int. Why is that? Why does it say it's reading a byte, but it reads in an int? And actually, the real answer here, once you hear the real answer, you might then ask, why doesn't it read in a short?
Yes, byte return -1 in case of end of file. So
Okay, well, we already mentioned that this guy needs to be unsigned bytes. Can we do unsigned values in Java? Java doesn't support the unsigned keyword, if you will. Older languages like C and C++ do. So to get a value bigger than a byte, so we can hold things bigger than 128, since we need to hold values up to 255, we're going to need something larger than a byte. Now a short would have cut it, right? We could have done it with a short. So I might question why didn't they have it return a short, but whatever. Okay, not that important. We happen to know, though, that this guy will never read in something larger than 255 because it's reading in unsigned bytes. Make sense? Why are the bytes unsigned? Why can't there be a negative byte it reads in? Will it help if I show you the picture? And there's nothing negative about that, right?
Mm-hmm. So
this guy's ultimately, I actually just had to read the text to make sure there wasn't something like horrible on there. I searched for Rickroll. Let's make sure I didn't grab an unfortunate. Okay, so this guy is a collection of bytes, right? Where a byte is 8 bits, zeros and ones. Negative numbers don't make sense in that. Negative numbers only make sense in math. Does that make sense? So that's why we have an unsigned element here. I still don't know why they didn't use a short. Maybe people are so averse to shorts that nobody uses them, including the documentation. So in any case, this guy's reading in an int, which means that we need to adjust our code here to take in an int, right? Which means we no longer actually have to convert it back to a byte there. We can just keep going like this. We just happen to know that phys.read will never give us something that's bigger than 255 or smaller than 0 because we're reading in unsigned bytes. All right, so I'll save that. I'll start our server. Compile, run, share, 3, and now we get a good collection of binary values. Make sense? So now that's looking kind of cool. Now, we're reading in those things. Now I need to send them somewhere. I need to write out to a file. So before we even think about sending it to sending it over a socket, we probably want to clone locally. Correct? I'm going to clone something locally. So what we're going to do is we're going to create a new file. Go to the documentation here. I'll just I'll go to our file class here. So we can give it a path name, and this will create a new file. So what we're going to do is we're going to create a new file called whatever the file they entered in is .clone, or maybe _clone or something like that. Okay. Actually, just so the MIME extension still works, let's just put clone in the front. So what we're going to do here is this is the file we're going to read in. Okay. I want to create another file called the clone, and this guy will be a new file, and this new file will be the word clone followed by this stuff, the old name of the file. Okay, so here's the file I'm reading in from, the file, and the file I'm going to be writing out my clone to is called the clone.
You should switch. You have the director my files, the clone word.
Oh, thank you, thank you, thank you. All right, so this would be clone, Rickroll, whatever the name of the file was. All right, here's our input stream for writing something, reading something in. Now let's go look at file output stream for writing something out. There's a file output stream. We can create one with a file. So we have that called the clone. And now we can write something out. Specifically, we can write 1 byte at a time to that file if we'd like. Okay? And that's what we're doing right now, is we're reading in single bytes and we're writing out single bytes. So while this guy's available, instead of printing it to the screen, we're going to say, well, I need to create my file output stream as well. Let me just put my file input stream right after the file we're reading in. And then I'll put my file output stream after the file we're writing out. Dead. File output stream. There's new file output stream the clone. Import java.io file output stream. All right, so here's the number of bytes we're going to read in. Then we're going to say fos.write fizz.read. Then we'll say done. We do need to make sure we do fos.close. Really, you should close your input and your output streams, but definitely close your output stream, otherwise it won't put end of file on there. All right. So now this guy should create a local clone of the file. So we'll go ahead and run our server. Compile, run, share, 3. There's the number of bytes. It's done. Here's our clone rickrolled. And there it is. Can't even tell the difference. Yeah, it's still creepy smile, everything. It's almost the same. Almost, but it's a clone, so it's not the same. These are new bytes. New bytes. Actually, they're the same bytes, but they're new bytes because they were copied into memory. New bytes. Okay, so now let's clean this up a little bit. So we're in a position to do our homework. It's like, oh.
I don't like that word.
Oh. So what we want to do is we want to write a couple of, we're no longer going to use this byte to binary thing. That was just for, for our eyes, I guess. We will go ahead and we want to, actually, do I want to clean this up? I think I don't want to right now. Yeah, I don't want to. So I'm going to leave it like that. So for your homework, we're going to create the client-server model, and when you choose to share a file like we're doing now, okay, we choose to share a file. In fact, I'll actually just show it. Do I still have my server running? No, I don't. What we want our program to do is when I run this, when we type in share, that's talking to the server, server will bounce back. Then it asks me which file. I'm going to say 4. Right now what we're doing is we're creating a local clone. What I want to do instead is I want to send this file over the socket to the server. Have the server receive it and write a local file on the server side. Okay, right now the client has a local directory called My Files. You probably want to create a local directory on the server called My Files. Okay, that one will live in the source folder on the server side. So now you'll read in from the client side, write it over a socket, even if it's happening on the same machine. Okay, it'll still be going over a socket. Then write it out to a new file inside of the My Files for the server. Now you've actually transmitted a file from point A to point B. Make sense? That's all we're doing. We just cloned locally here. Now we're cloning over a socket. We're not doing all the extra stuff about sharing files with multiple people or anything like that yet. We're just cloning remotely, if you will. Make sense? All right, I'm going to go ahead and put both of these projects, both of these files up on GitHub and give you the link so you have my current starting point for the client and server. All right, I'll give you a link to that, and I'll also give you a description of what the code should do. And I'll put that up, and that is due on Friday. Should not take that long. It's only a couple more lines of code from what we're doing right now, except you'll have to update the server a little bit. Put some new code in the server. Make sense? All right, I will see everybody on Friday.